Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fiazid bin Harizamil. So I will present for the one sample test for our database. So we are using hypothesis testing one sample. So basically we want to determine whether the mean percentage of population pregnancies at least once are greater than 30%. So we use the population of 768 sample of the pregnancies woman. Right, for the working analysis, we let the mean population, which is the mean percentage of population pregnancies at least once. So for the null hypothesis, we want the mean percentage is equal to 0.3, which is the 30%. And for the alternative hypothesis, we want the mean percentage is greater than 0.3. So we use the significance level alpha equal to 0.05. So for the z value for the 0.05 is 1.96. So I have create the R script in the R language. So use the database of diabetes. Then I use three library: Psda, ggplot2, and dplyr. Okay. So for the R script output, which is we got the value of the z value using the 0.3 alternative greater than 0.3, then the sigma then the confidence level is 0.95. So we got the z value is 29.156. So I use the z test function. So we got the z value is 29.156. And then for the plot, the z value, which is the 29.156, or we can just simplify at 29.16, is falls within the critical region, which is greater than 1.96, the confidence level. So for the conclusion, the z value for 0.05 is the 1.96, and our z value is 29.16. Since the z value is greater than the z 0.05, so the test statistic falls within the critical region, where we reject the null hypothesis. Therefore, there is sufficient evidence to conclude the mean percentage of pregnancies at least one is greater than 30%. So by the database that we get and the value that we got, the amount of women who are at high risk of getting diabetes are higher in number, as pregnancies can make women vulnerable to diabetes if they do not take precautions, which then could affect their health and the health of their future child. Thank you. That's all from me.
Okay, Bismillahirrahmanirrahim. Next, I'm Adik Wafi, and now I will explain for the third test that we had, which is the correlation test. So, for the variable, I will take BMI of our data sample, which is 768 women and their blood pressure, and then this is one for the R script. So for the X and Y column, I input them manually by using shortcut I learned from YouTube. And then for the console part, after the data had been loaded into X and Y column, and then just put the command core.test X and Y, and then it will automatically calculate the Pearson product moment correlation. And then I got the answer, which is 0.2818053. So as you can see, the t-test got positive number, which means the slope will be positive. So as you can see, this is the graph. So you can see the slope is slightly go up. And then this BMI for the x-axis and blood pressure for the y-axis. So as you can see, this one, this two variable is had what is it? Yes, linear correlation. And so for the conclusion, as I states earlier, for the t-test we got the value, and so for the critical value, which at 5%, which is 1.97241. So as you can see, it is two-tailed test. So null hypothesis will be reject if the test smaller than native 1.97241 or larger than positive number that number. So otherwise we will fail to reject null hypothesis. So as you can see, the t-test value located fall on fail to reject. So we fail to reject null hypothesis. That's all from me. Thank you.
Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. So I will continue the presentation with our regression test. Okay, for our regression test, we use two variables, which is age and diabetes pedigree functions. So age will be our independent variables, or the x, and diabetes pedigree function will be the dependent variable, which is y. So this were taken from the data set of 768 women. So on our data scripts, so this is our R script where I take the data from the diabetes.csv, which is our data set, and then I put it inside of the x axis, which is the age, and y axis, which is the diabetes pedigree function. So I plot the model and find the R squared. And at the right side, this is the output on the console, which shows that the R squared value, which is 0.00112632, and the intercept. So intercept, which is the B0, which is 0.440456, and the B1, which is 0.009455. So this is our graph, and as you can see, the line of the linear is almost it doesn't have slope, so we cannot determine whether it is positive or a negative relationship. And lastly, so what we can extract the information from the data set that we get. So from the R output, I get for the Y, we get B0, which is 0.44, and sorry, B1, B1, which is 0.009455. So R square, I get 0.001. And from the graph, we extract the information. So the relationship are very weak. So there are almost no linear relationship between the independent and dependent variables. So we can conclude that the diabetes pedigree function does not depend on the age of woman. As you can see, the value of R squared is also very small compared to another data. So we can conclude that it is not dependent. All right, I think that's all. Thank you.
Assalamualaikum. My name is Muhammad Ali Benifni, and today I will present about the ANOVA test of our project. Okay, so in this data analysis, we use ANOVA test to test the amount of insulin taken means by analyzing the simple variances. The population is split into 4 different categories based on the amount of pregnancies, and the samples are randomly selected to get an equal sample size. The significance level used to test the null hypothesis is A equal to 0.05. All right, so our hypothesis, null hypothesis is all the mean are equal, and our alternative hypothesis is at least one mean is different from the other. All right, so we use the RStudio to calculate and analyze to do the ANOVA test. Okay, so this is the output. Okay, so the mean that we get between sample is 147.697, and the standard deviation between sample is 17.765, and the variance between sample is 3471.432, and the variance within the sample equal to 6816.515. And to find the F critical value, with the formula variance between sample divided with variance within the sample, which we get 0.508, right? And so from the result, since f of the test statistic is smaller than f of the critical value, which means we fail to reject the null hypothesis, as there is sufficient evidence to claim the different amount of pregnancies have the same means of amount of insulin taken, right? So insulin actually helps for the body to receive the glucose from the blood, right? So the glucose in the blood are being transferred to the cell with a force called this insulin, all right? So when someone has low amount of insulin, which means the glucose from the blood cannot be transferred to the cell of the body thoroughly, okay? So the possibility of them getting a diabetes is high. And also for those with high amount of insulin also have the possibility of getting diabetes due to the excess weight from high insulin. That's all for me. Thank you.